Okay, I just want you to look at these a second and go ahead and pause the computer, and I want you to go ahead and simplify these. So the direction would be simplify on all of these, and just think about what you're doing. Don't just memorize rules, but actually think about what you're doing. So pause the computer now and try to do all of these, and then I'll come back and do the solutions to these. So try not to cheat, just pause right now, do them all, and then we'll come back. All right, so hopefully you didn't cheat. All right, so let's look at these. The one thing you need to understand is when you add and subtract, that's like cats and dogs. So you're going to put all the things that are alike in a pile, and you're going to end up with a lot of piles, like a pile of cats, a pile of dogs, a pile of bunnies, a pile of guinea pigs. So this one is going to not end up being a single answer. And this one down here would be the same thing, and this here. So when you're adding and subtracting, you're collecting like terms. So you're putting things that are alike together, but you're not creating a new unit. Everything else, like this one, this one, this one, this one, and this one, you are creating a new unit. So your powers are going to change. All right, so kind of knowing that, and then also knowing that this you can mush into a complete chunk. This is a complete chunk. This is a complete chunk. Same thing here and here is kind of helpful knowledge. So those are going to simplify to a single term when you're done. All right, so let's look at this one. So let's see. I have 2x squared here and then 4x squared. And those literally are squares, right, that are x by x. And so I have 2 of them and I have 4 of them. So I have 6, but again, they're not changing shapes. They're squares. These are cubes. I have 2 of them, cube shape, and I'm taking away 1 of them, so that means there's just 1 cube left, and you can either write 1 or just x cubed. And then you just owe 2, so maybe you owe 2 things over here. And so that's the best you can do. And usually we would probably write this in what we call descending order, meaning that I would probably go ahead and put the highest power first, the highest degree, then the second one, and then the constant last. Okay, usually we like to kind of write them going down like a nice little order. All right, the next one. This is multiplication. You are creating something new, like volumes, something else that you don't have before, so things change. Let's see, so 2, -1, 4, 2, and that. So if you multiply, you get what? 2 times 1 is 2, there's 8, 16, 32. Now is it positive or negative? Let's see, these two will pair up so it's positive. So I have a positive 32x, and again I'm creating something new, so my power is going to change. I have 2 x's, 3, 4, 5, 6, 7, 8, 9, 10 x's. And notice I can mush my answer into a single term. All right, next one, a power to a power. This means I have 3 sets of this, or 3 groups. Numbers are normal. I'm going to get 27. And I have 3 sets of 6 would be 18. Now again, I'm going to get a single chunk or a single term, and if you're not sure, write this out 3 times, because that's what it means. You have 3 sets of it. And you should be able to see the 27. You should be able to see all your x's. All right, same thing here. I can mush it because I'm creating area, volume, something new. That's a -8. Numbers are normal. How many x's do I have? Power should change, so there's 1 over there, so that's 3. And I have 1 over there and 2 there. And so there's that. And again, single chunk when you're done, so you can mush it into 1 term. Now, this one is x squared y. This is xy squared. This is as simplified as that gets. An x squared y would be like a x by x, and it'd be y long. Look like that. This guy would be y by y, but it'd only be x wide. So those are not the same shape. All right, and if I have 4 of these and I owe 2 of those, again, they don't collect like terms. So this is the best answer you can get. Next one, divide. Numbers are normal. 2 goes in there. -12 always has, always will. And now you're canceling your x's. So you have 6 up here, 2 here, so when you cancel, there would be 4 left. And again, you can get a single term out of that. You started with these 2 monomials. When you divide, you're going to get a single monomial for an answer. All right, next one, I am adding. So this is like cats and dogs. So you're putting these in a pile. So we're just combining things that are alike. So you're going to put those 2 guys in a pile. Let's see, you have 3, you owe 4, so you owe 1, x to the 4th. And then you have 2x and 8x, so you have 10x. And that is the best you can do, because cats with cats, dogs with dogs, you're collecting like terms, and that's it. And then the next one means you have 4 sets, or 4 groups of that. Numbers are normal. -3 times -3 times -3 4 times is, what, 81? And if you have 4 sets of 3, you would end up having 12. And again, if you're not sure, write it 4 times so you can actually see what you are doing. All right, there you go. I hope that helps. The other thing to think about real quick is, let me erase this. I guess we can add a little bit more to this. If you're doing the distributive property, just make sure you do that first. And again, sorry, this is a lot to erase. All right, this eraser's not working very well. Let me try it again. There we go. I think it just quit working. All right, so the other thing is, with the distributive property with algebra, remember, without it, you can't do anything. So if you have something like this, all right, so you're going to do the distributive property first. And notice you're going to distribute that negative to everything. So that's going to become negative. That's going to become positive. That's going to become negative. Now you're going to collect like terms. So your x's, oopsie, I didn't mean to do that. Those x's are like, and then what your numbers, constants are like, and then those are kind of their own little deal there. So I have 2x and 4x, which is 6x. And I owe x squared, there's no more of those. And then 8 and a -6 is I have 2. Again, we'd probably put this in descending order. So we put the highest degree first and kind of work our way down. So that would be something that you would do there. Another case of the distributive property might be something like x plus 2 squared minus, I don't know, let's do x plus 3, x minus 2. So again, you're going to have to simplify those first before you do any adding and subtracting. So again, when you multiply, things change. And if you want to do the box method for this, you can see x plus 2, x plus 2. So you get x squared, 2x, 2x, and 4. So that's what x squared plus 4x plus 4 is the answer to that. And usually you get a trinomial on those. All right, and then you're going to subtract all of this. So parentheses are not optional. You need them. All right, so let's do the box for this. X plus 3, x minus 2. So I get what? X squared, 3x, -2x, and -6. So x squared, and again, I do get a trinomial. You don't always get a trinomial. There are a few situations where that doesn't happen, and we can talk about when that doesn't happen in class. All right, so now I'm going to go ahead and distribute. So I get x squared plus 4x plus 4 minus x squared minus x and plus 6. So again, notice when we multiplied these out, powers change, right? We got that, and then powers change, we got that. But now we're just collecting like terms. So cats and cats, dogs and dogs, guinea pigs with guinea pigs. These add up to 0, so those go away. I have 4x, I owe an x, so I get what? 3x. And I have 4, and I have 6, so I have 10. And again, when you add, your powers don't change because you're just collecting like terms. So you're putting all your x's in a pile, all your constants in a pile, and so forth. All right, hopefully that helps. Again, you might want to just start the video over, try again on your own, and then kind of see how you do. All right, have a great day.